Hi, this is Luke from the Stats Medic, and in this lesson we're going to talk about confidence intervals for difference in means. Now, previous in the course, we had done confidence intervals for one mean, and those are considered one sample problems. And in one sample problems, we're trying to estimate a single mean. In this lesson, we're going to be looking at two sample scenarios, and in this case, we're going to be trying to estimate the true difference in means, mu1 minus mu2. Now there are two learning targets today, and the first one is really just going to help us arrive at the second one. So the first learning target says, determine whether the conditions are met for constructing a confidence interval for a difference between two means, which will lead us to the second learning target, which is to construct and interpret a confidence interval for a difference between two means. And you can expect by the end of this lesson, we'll be able to do this using the four-step process of state, plan, do, conclude. In this activity, we're going to try and find out which cookie has the most chips. So we're going to be comparing Chips Ahoy brand chocolate chip cookies versus Meijer Chipsters chocolate chip cookies. So Meijer is the local grocery store here in Grand Rapids, Michigan, but you could use whatever store brand chocolate chip cookies are closest to you. So here's what the question says. Is there a difference in the number of chocolate chips in Chips Ahoy cookies versus the number of chocolate chips in Meijer brand cookies? Each pair of students will count the number of chocolate chips in one Chips Ahoy cookie and one Meijer Chipsters cookie. Due to the factory processes, we can assume the population distribution of the number of chips are approximately normal and that the samples are random for each type of cookie. So number one says record the number of chocolate chips in each cookie, write them on the board. So I actually went ahead and did this for one cookie from Chips Ahoy and one from Meijer Chipsters. And in my cookie, I had 22 chocolate chips in the Chips Ahoy, and I had 18 in the Meijer Chipsters. Now you can try this on your own to see if you get similar results. But we need class results here, because if you look at number 2, it says find the mean number of chocolate chips for each type of cookie, the standard deviation for each type of cookie, and the difference of means. So we're going to use class data for my first hour AP Statistics class. And with my cookie and then their 27 students, we had a total sample size of 28. And here are the values that we got. For X1 bar, the average number of chocolate chip in Chips Ahoy, we got 21.56 with a standard deviation of 2.49. For the Meijer Chipsters, we had an average number of chocolate chip cookies of 18.22 and a standard deviation of 4.51. Now the next thing we had to calculate here is the difference of the means. So we just had to take X1 bar and subtract X2 bar, and that's going to give us a difference of 3.34. So based on our sample, Chips Ahoy has on average about 3.34 more chocolate chips than Meijer Chipsters. Now you have everything that you need in order to complete the rest of the activity. So if you could do questions 3 through 6 on your own, try those out, and then come back to the video to see how you did. So go ahead and pause the video. Now, so let's take a look at your answers from the activity. Question number 3 should be a review for you, asking you about the sampling distribution of X1 bar minus X2 bar. And so hopefully you got that the shape is approximately normal, and we'll talk about why in just a minute. The center, we have the formula for the mean of X1 bar minus X2 bar, which is mu1 minus mu2. And at this point, we don't know what mu1 minus mu2 is. In fact, that's what we're trying to estimate with our statistic x1 bar minus x2 bar. Now for the variability, we have this formula here, which is the variances being added together from the two populations. Now the reality is that we are not going to know the standard deviation of the populations in this case, and so we're going to use the standard deviation of the sample. And so this standard deviation here will turn into the standard error of x1 bar minus x2 bar. So let's go ahead and write in that formula. The standard error is the square root of s1 squared over n1 plus s2 squared over n2. And of course, that's the reason, again, why we're going to need to use a t-distribution instead of a normal distribution, is because we are now estimating the standard deviation of the population. So let's move to question number 4, where we will check our conditions. And these 3 conditions are going to look identical to the conditions for a confidence interval for a single mean, but the big difference here is that we have to check each one of these conditions for both populations, the population of number of chocolate chips for Chips Ahoy, as well as for Meyer Chipsters. So looking at the random condition here, you'll notice that we're saying that the samples are random, plural there, and that's because there are 2 samples here. Now the other important thing to note here is that these 2 samples are independent. For the 10% condition, we have to check it for both samples because we're sampling without replacement. So we check it for the Chips Ahoy cookies as well as the Meyer Chipsters cookies. And then for the normal condition, we have right from the stem of the problem that the population distributions are approximately normal. Notice here that we're using the plural population distributions because there are 2 population distributions. So now we're ready to move on to the calculation of the confidence interval. So we started with the general formula here, which should be very familiar to you at this point in the course. And then you had to come up with your specific formula on your own. Well, we know the point estimate is always going to be our statistic, and we have our statistic up here, x1 bar minus x2 bar. We definitely want to have a t-star here, and the reason is because we're using the standard deviation of the sample rather than the standard deviation of the population. And so then over here, we go ahead and just plug in all of our values. Now, I did have to get this t-star value, 2.052, from Table B. So let's talk about that real quick. In order to use Table B, you're going to have to know your degrees of freedom here. And I'm going to guess that you use degrees of freedom 27. Okay, this is what's called the conservative approach to getting the degrees of freedom. And the way the conservative approach works is that you look at your 2 sample sizes. In this case, both of our sample sizes are 28. And you find the degrees of freedom for each one of them. Well, of course, the degrees of freedom is 27 for both of them. And then you take the lower of the 2 degrees of freedom. And in this case, they're both 27, so the lower of the 2 degrees of freedom is 27. So we call that the conservative degrees of freedom. So with our conservative degrees of freedom of 27 and our confidence level of 95%, we arrive at a t-star value of 2.052. And ultimately to arrive at our confidence interval of 1.34 to 5.34. Now, when we do this confidence interval on the calculator has a very fancy way of finding the degrees of freedom using a complicated formula, and is going to give you a slightly different confidence interval. So let's go ahead and take a look at what that would look like on the calculator. So start by going to the Stat menu, and then over to Tests, and then you're going to have to scroll down until you find a 2-sample t-interval, and it should be 0 here. Go ahead and hit Enter. And you have a choice here on whether to input data from a list or summary statistics, and we have summary statistics for this context. So go over to Stats, and then let's put in our values. For x1 bar, we got 21.56. For standard deviation of the first sample, we got 2.49, with a sample size of 28. For our second sample, we got a mean of 18.22. with a standard deviation of 4.51 and the same sample size of 28. Next, we set our confidence level. We want a 95% confidence interval. For pooled, by default, it should be on no, and that's where you want to leave it. We only pool if we somehow think that the standard deviation of each population might be the same. But for AP statistics, we will always say no for pooling. So go ahead and hit calculate. And you should get this result here, which is a confidence interval from 1.3753 to 5.3047. Now you'll notice that this degrees of freedom is different than the one that we had in the activity, and that's because the calculator is using a fancy formula to calculate this degrees of freedom, and you'll notice that it's higher than the conservative degrees of freedom of 27. So let's go back to the activity and make a note about what the calculator would produce for a confidence interval. So from the calculator, we have a new confidence interval, which is 1.38 to 5.30. And the big difference here is in the degrees of freedom that was used. In our solution here, we used the conservative degrees of freedom of 27. And in the calculator solution, they used the degrees of freedom of 42.06. Now realize that both of these solutions would get full credit on the AP exam, but one suggestion here. If you're going to go with the calculator answer and the calculator degrees of freedom, then this T star value is no longer correct. And so I would just leave it as a variable of T star there when you're showing your work. Now let's take care of the last question here, number 6. Do we have convincing evidence that there is a difference in the average number of chocolate chips in a Chips Ahoy and a Meyer Chipsters cookie? Well, the answer is yes here, and if you look at our interval, both our interval as well as the calculator interval, you'll notice that all of the plausible values for the difference between the mean number of chocolate chips is positive. So we think that this difference is going to be positive. So we do have convincing evidence that there is in fact a difference in the average number of chocolate chips. So I've justified this by saying that all of the plausible values are positive. And there's another way of saying this. If all of the values are positive, that means that 0 is not contained within the interval. If 0 were contained in the interval, we would think it's plausible that there is no difference. So one other note that we're going to add in here. We got a confidence interval which is positive, positive. And that means that we do have convincing evidence. In fact, convincing evidence that Chips Ahoy has more chocolate chips on average. If we had got a confidence interval that was both negative and negative, that would also be convincing evidence of a difference, but in the other direction, that the Meyer Chipsters had more chips. It's only when we have an interval that goes from negative to positive that we do not have convincing evidence. And the reason is because that interval would contain the value of 0, and we would say that it is plausible that there is no difference. So let's see if we can summarize our learning and the important ideas. In the first learning target, we're going to remind ourselves of the conditions that are necessary for a confidence interval for a difference in means. And these are the same 3 conditions that we had when we did a confidence interval for one mean. It is the random condition, the 10% condition, and the normal condition. The big difference here is that all 3 of these conditions need to be checked for each population, because there'll be 2 populations here. Now, the second learning target was about constructing and interpreting a confidence interval. So let's just do a quick reminder of some things that are needed in order to do the 4-step process here of state, plan, do, conclude. For the state, we need to clearly identify the parameter. And in this context, the parameter is going to be the true difference in means, mu1 minus mu2. And then the statistic that we're going to use to try and estimate that parameter is x1 bar minus x2 bar. And then, of course, the other thing to include in the state is the confidence level. In the plan, we need to start by identifying the inference procedure. So this is going to be called a 2-sample t interval for mu1 minus mu2. Now, in terms of the conditions, we Just talked about those conditions there. Those should also be included in the plan. For the do step, the general formula for any confidence interval is going to remain the same. Point estimate plus or minus the margin of error. What's new for us here is the specific formula. So in our specific formula, the point estimate is our statistic, x1 bar minus x2 bar, plus or minus, and now for the margin of error, we need our critical value, t star, times the standard error here, which is the square root of s1 squared over n1 plus s2 squared over n2. Now the other thing we should make note of here is this t star value, which we're going to get from table B. And there are two different ways to approach this. There is the conservative degrees of freedom. And the conservative degrees of freedom, we're going to take the lower of the 2 degrees of freedom. So n1 minus 1 and n2 minus 1, you would take the lower of those two values. Or you can take the degrees of freedom from the calculator. And then finally, to conclude, hopefully at this point in the year, you're very comfortable making a conclusion for a confidence interval.
Now that we've completed the important ideas, let's go ahead and try this check your understanding problem on your own here. It is going to be a confidence interval for difference in means, and I'd like you to use the full 4-step process here. So go ahead and try this on your own and then come back here to check your answers. So you can pause the video now. Let's see how you did on the check your understanding problem. So for the state, we want to start out by identifying the parameter that we're trying to estimate here, which is the difference between the two means, and then making sure that it's clear that we're referring to the population here. We're using the word true, and then also indicating the order of subtraction here. So we are going to do the people aged 15 to 19 minus the people that are aged 75 and older. And then the other thing you need in the state is the confidence level, which was given to you as 95%. For the plan, we have to start by naming the procedure here. This is definitely to sample. It is going to be T rather than Z because we're dealing with means. It's definitely an interval rather than a test. And the parameter, again, here is mu1 minus mu2. Now, let's check our 3 conditions here. For the random condition, yes, we need random samples, but it's important that those 2 random samples are independent. So make sure that you have the word independent and that you are actually referring to multiple samples there. And I'm going to go ahead and add in the so what here. So we check that condition and we know the condition satisfied, like so what? Well, because we have random samples, we can generalize to both populations. So that's an important part of inference, is knowing which populations we can generalize to. Now, the fact that we have independent random samples, that's actually what allows us to add the variances down here in the formula for in the margin of error. Now, the 10% condition we check anytime we are sampling without replacement, which is definitely the case here. And our population sizes are very, very large here if we're talking about all people 15 to 19 and all people 75 and older. So we're definitely good there. The so what here is so sampling without replacement is okay. That's why we check the 10% condition. And then finally, the large sample normal condition. Both of our sample sizes are very large here, much greater than or equal to 30. So by the central limit theorem, our condition is satisfied here. The so what on this one is about the sampling distribution. So we're going to say here, so the sampling distribution of x1 bar minus x2 bar is approximately normal. So now that we've checked our conditions, we can actually do the calculation here. Remember, you always want to include the general formula, which is true for any confidence interval, but then the specific formula is specific for calculating a confidence interval for the difference of means here. And then you go ahead and plug in all your numbers from the problem. And one of the things that we had to think about here was the T star value, which of course depends on the degrees of freedom. So you'll notice here that I just chose the conservative degrees of freedom, which is the lower of the degrees of freedom from the two sample sizes of 975 and 1050. So we go with this one, degrees of freedom, remember, is n-1. So in this case, 974. Now, unfortunately here, with the degrees of freedom 974, when you go over to table B, you're of course going to notice that there is no 974 for the degrees of freedom, and you'd be tempted to go to 1000, but remember, you have to actually go to the lower, you have to round down there to be conservative. So we actually have to use degrees of freedom 100, and with the 95% confidence interval, that's going to give us a T star value of 1.984. So I've indicated here that from table B, we're using degrees of freedom 100, which gave us a T star of 1.984. And you'll notice, of course, that our interval has all negative values here, and that's because the younger people, 15 to 19, are reading much less than the people age 75 and over. So our conclusion, we are 95% confident that the interval from negative 38.2 to negative 33.8 minutes, so make sure that you have your units in there, minutes, captures the true difference in mean amount of time that people age 15 to 19 and people 75 or over read per day. Now, the last part of that confidence interval that you see here, difference in mean amount of time, that is taken directly from the wording of the question here. So if you look up, we are just taking those words right from the question and putting those into the conclusion. Now, the last thing that I want to mention here is that there is a calculator function which will do a two-sample confidence interval for the difference of means, and it'll give you a slightly different interval. It would be negative 38.18 up to negative 33.82, and that's because the calculator is using this fancy formula for calculating the degrees of freedom, which was about 1101.